optimized price to handle a request. I have just started our Docker container with the respective Flask service. I will quickly go into the demo for genetic algorithms, which is a short demo to search for a specific string which was predefined before. So currently the genetic algorithm searches for the specific string here and tries to guess what string could be meant here. As we can already see, this means knowledge is everything. So if we compare this to a brute force algorithm, we would have 27 types of character plus the space bar. And if we assume this whole sentence consists of 30 characters, this would be 27 squared 30, for example. So we would have a really long time to search for the correct sentence here, yeah. And we can really see that genetic algorithm is able to find the solution within a short amount of time. Let's jump into the company pricing. First, we have a table how all of the specific values, especially for the dynamic price, is calculated. So this tries to optimize the profit. The profit calculates revenue minus costs. And the profit percentage formula is, of course, profit divided by cost price times 100. So here we can see the options which we can set. First, we have a central latitude and a central longitude. So this is currently the city center of Vienna. We have a radius of 10 kilometers. With a start latitude and end latitude longitude from Währingerstraße 26, actually Währingerstraße 29, to Schottentor Hauptgebäude University of Vienna. So if we assume that we have a base price per minute of 30 cents here, we can calculate the respective dynamic price. Here in the results we see the different individuals which are optimized to calculate the best dynamic price for the company. We currently have a profit percentage of 44%. So we see our base price here. Customer loyalty would be false as default. The day of the week, it's currently Tuesday. Loyalty discount would be 10%. Remoteness is false because our start and end latitude lies within the radius. And our remoteness surcharge would be 15%. Our current weather condition in Vienna is moderate, and the weather surcharge would be plus 20%, and the weekend surcharge would be plus 10%. We also can see how this price changes if we change the different types of parameters. For example, if the customer is a loyal customer and we try to calculate the respective price here, we see that the price decreases. So we would now have a dynamic price of 33 cents. If we do the same with the weather condition and change it to bad, we would increase the price though, because now we assume that it will be a higher demand. Here in the individuals you can always see the specific individuals which we multiply the price with in order to get the best dynamic price here. We can also do this for the day of the week. On weekend we expect a higher demand, so let's say it's Saturday, so this will also increase the price since this is a higher demand. We now have 63 cents per minute. For the remoteness we can do the same and tell the algorithm that we are currently not in a remote area, and this will also increase the price to 87 cents per minute. The algorithm is not allowed to exceed a specific amount of a specific bound. So we set the bound from 0.8 to 0.2. So we can really see that the algorithm now tries to multiply everything, almost everything except the customer loyalty times 1.2. So in order to get to the best dynamic price here. So for example, if we turn off the customer loyalty now to false, we will even have a higher price with a higher profit, and now the customer loyalty also gets multiplied by 1.2. We can also set the different kind of discounts or surcharges we give. For example, for the loyalty account, we could give 20%. For the weather surcharge, we could multiply it also with 30%. For the weekend, same here. For the remoteness, same here. So if we specify these constants within the algorithm, the price will be recalculated here as well. And our dynamic price with the genetic algorithm will find new individuals to calculate the best price for the company.
The customer pricing part shows the work of genetic algorithms that aims to maximize customer satisfaction. Here is the input values. So first comes customer rate. It should be value between 1 and 5, where 5 is the best customer rate. Then comes the car class. It can be either economy, business, or luxury, where luxury is the best car class that gives the most satisfaction to the customer. Then is base price. It can be either a price per minute or the whole trip price. Let's say 30 euros, 15 euros. The algorithm is flexible in this case. And next comes the car location, customer location, and destination location. These are the basic trip locations that can be addresses because it's connected to the Google Maps. So it will identify these addresses in real time. The result of the algorithm are best discount percent, so the best percent that we can get in the given input. Then it's best price. It's based on the best discount percent and base price that we get as an input. And here are the individual values that form this best discount percent.
I will show you now the optimization of the cost calculation for one right from start to end. But first we have to put in the coordinates of the start point and the destination. Then we can choose between a car class and the total kilometer that has already been driven by the customer. This is the base for the loyalty discount. Then we click on calculating. Now we can see the minimal cost of the ride, which is 19.52, and the best individuals. I put some borders in the cost per kilometer and the car class, which is here 0.5 and here 0.8. This will be taken then in the cost calculation.
In a project, there's also a Swagger included, where you can access a Swagger page where you can get an overview over the different endpoints. You can access this page with the base address /docs, and you have in short description over the endpoints and a link to the paper to get an overview over genetic algorithms, and you also have a link to the implementation. You also have the structures of the different JSONs for the requests and responses, where you can get an overview over the data type that is required for the request and the data type you will get back with the response. For example, the response for company, it's looking like this, where you also have like a list with different floats. And for each of those endpoints, you also have like the option to try them out. And if you try them out, you will get back the response according to the request you will send. And for example, this is the response body for the company endpoint.